So on here, this is 7.3 Windows of Graphs. So the volume y of coral in cubic centimeters is modeled by the equation y equals 1,200 times 2 to the x, where x is the number of years since the coral was measured. Three students used graphing technology to graph the equation that represents the volume of coral as a function of time. So now we're going to describe how well the graphing window does or does not show the behavior. So on here, in this situation, the window is really focused in. So if you look here, I can see the number of bacteria here in graph B goes up to 1,000,000, whereas this only goes to 2,000. And in this case, the graph kind of looks like it could be linear. So for graph A, this is a bad window. And the reason it looks like it could be linear. And then if you look here, this would be a good window. We have a scale on the y-axis. We have the x-axis. And you can see the curve of the exponential function. So I'm just going to write good window. You can see the curve. And then also I'm going to notice here that the y-axis is labeled. And then on graph C, again, this is a pretty good window, but you don't have the y-axis labeled. So now for each graphing window you think does not show good behavior of the function well, describe how you would change it. Well, for this one, I would zoom out. So keep the scale on the x-axis the same, but make the y-axis scale bigger. So I'm writing zoom out, make the y-axis scale bigger. So we would make the changes that we want using graphing technology. So I'm going to show you how to do that on here. If we put in the function, so let me just clear out what's in there. Y equals, I'm going to clear out this function. I'm going to put in 1,200 times 2, and then you just press to the caret key and then put to the x power. Now to change my window, there's a few things. Now if you notice here, the minimum on the x-axis, it goes from -2, and then the maximum, it goes up to 4, and we count by 1, so that's what the x scale is. Now if you notice, the y minimum here is 0, and then we could go up to about, 1,000,000. Which if you're counting, that's 1 with 6 zeros behind it. Now, obviously, and I need to put that in for the y max. And then just clear out the minimum and put in 0. Now, this y SCL, that means a y scale. Well, if I'm counting from 0 to 1,000,000, I'm not going to count by 1. So you need a scale for what this represents here. So I'm going to make that scale 100,000. Then I'm just going to hit graph. Oops, and if you notice, my x scale is off because in this graph, I needed to go over to x is about 10. So if I go back to my window and I change the x max to go from -2 to about 10, and then regraph the function, you can see the function really starts curving off as long as I have the right x value. So we had to make the y-axis scale bigger and also the x-axis. I'm going to put that in here. Just put and the x-axis.